Right. Hi friends. Now we'll learn about the discrete probability distributions. There are two discrete distributions here. We'll study about the binomial and Poisson and multinomial distribution. So first of all, we'll see binomial distribution. Before that, I'll go for what is the yes. So first of all, we'll go for the what is the about the distributions. Frequency distributions can be classified into two ways. One is observed frequency distribution, and the second one is theoretical distribution. What is the observed frequency distribution? The observed distribution, frequency distribution are based on the actual experimentation or observation. So whatever the original experiment is there, that observations are called observed frequency distribution. Whereas theoretical distribution, or I can say mathematical distribution, if a certain hypothesis is assumed and it is possible to derive mathematically such distributions called theoretical distributions. Now we'll go for the theoretical distributions. They are classified into two parts. One is discrete theoretical distributions, and the second one is continuous theoretical distributions. So now in we study here about in discrete theoretical distribution. One is binomial distribution, Poisson distribution, and multinomial distribution. Whereas in continuous theoretical distributions, normal distribution, exponential, and gamma distribution. Now, first of all, we'll see what is a Bernoulli trial. Right. A Bernoulli trial has a corresponding Bernoulli random variable which counts the number of successes in a single trial. The only possible values of this random variable is 0 and 1. So the Bernoulli having only two outcomes, so possible random variables are only two, those are 0 and 1. The random variable takes the values 1 if it is success occurs and takes the value 0 if it is failure occurs. So that means the Bernoulli random variable which takes only two values, one is 0 and 1. Right? The random variable takes the value 1 if success occurs and takes the value 0 if failure occurs. Let capital X be a Bernoulli random variable then with parameter p, where 0 is less than p is less than 1, then the probability function p of x is given by p if x equals to 1, 1 minus p if x equals to 0. Now we'll see what is the mean of the random variable. Now we have the expectation of x, or mean formula summation x into probability of x is nothing but 0 into 1 minus p plus 1 into p. Why? Because we have the Bernoulli distribution function, probability function p of x equals to p if x equals to 1, 1 minus p if x equal to 0. That's finally to find the mean of the random variable expectation of x, or we can say mu is equal to summation x into p of x, 0 into 1 minus p plus 1 into p, so is equals to p. Now we'll see what is the variance of the x. Now, variance of the x equal to summation of x minus mu of x whole square into probability of x. So, 0 minus p whole square into 1 minus p plus 1 minus p whole square into, so p into 1 minus p plus into p plus 1 minus p. So, p into 1 minus p is the variance of the Bernoulli random variable. Now, we'll see what is the binomial distribution. Now, let capital X be the number of successes in an independent Bernoulli trial. So, total number of trials are n. So, X is the number of successes. Now, each with the probability of success is P. Then the probability distribution function P of X of capital X is given by P of X equals to NCX P power X into 1 minus P whole power n minus X, for X equals to 0, 1, 2, 3, so on n. And we can say if p is the probability of success, then we can say 1 minus p equals to q is the probability of failure. Now, so total number of there are n independent trials. So x is the number of successes. So in other words, we can say the probability the function p of x equals to ncx p power x into q power n minus x, where p plus q is equals to 1. Now x is the binomial random variable with parameters n and p. We write x takes a binomial distribution n comma p. Then p of x equals to ncx p power x into 1 minus p whole power n minus x. In other words, we can say 1 minus p equals to q. Then p of x equals to ncx p power x into q power n minus x, where p is the probability of success and where q equals to 1 minus p. Now, here n is the number of independent trials, p is the probability of the trial of each success, each trial, and the other q equals to 1 minus p, x is the number of success required. Now, what are the conditions to apply the binomial distribution? So the main conditions to apply the binomial distribution are: first one is the number of observations small n is fixed. Each observation is independent. Third one is each observation represents one of the two outcomes, either success or failure. Fourth one is the probability of success P is the same for each outcome. So if these four conditions is compulsory to required to apply the binomial distribution. Now we'll see what is the mean of the binomial distribution. The mean of the binomial distribution. So x will take the random variable, binomial random variable. Then mean mu equals to r expectation of x equals to, we have the formula summation of x into p of x. Now we'll go for x equals to 0 to n, x into ncx p power x into q power n minus x. So expand this one for x equal to 0. So 0 plus 1 into nc1 p power 1 q power n minus 1 plus 2 into nc2 p power 2 x power q power n minus 2 plus so on. So if I'll take np common, because nc1 equals to n factorial n minus 1, n into n minus 1 by 2 factorial. So this is nc2, 2 times of nc2, n into n minus 1 into n minus 2 by 3 factorial, so on. So if I'll take np common, then q power n minus 1, next n minus 1 into p into q power n minus 2 plus n minus 1 into n minus 2 by 2 factorial p square into q power n minus 2. So which is the expansion of p plus q whole power n minus 1. So np into p plus q equals to 1. So 1 power n minus 1. So np equals to 1. np is the mean of the binomial distribution. So if x takes the binomial distribution, then mean of the binomial distribution is np, where n is the number of trials, p is the probability of success. Now we'll see what is the variance. So to find the variance of the binomial distribution, we have variance formula equals to expectation of x square minus expectation of x whole square. In other words, expectation of x square minus mu square. So is equals to summation expectation of x square is x square into p of x minus mu square. So summation x equal to 0 to n x square into p of x minus mu square equal to x equal to 0 to n. I'm writing x square as x plus x minus 1 into x into p of x minus mu square. Now summation x equal to 0 to n x into p of x plus x equal to 2 to n x into x minus 1 into p of x minus mu square. So if I evaluate this one, then I'll get np plus n into n minus 1 into p square minus n square into p square. So np into 1 minus p. So npq. So npq is the variance of the binomial distribution. So if x capital random variable x takes the binomial distribution n comma p, where n is the number of trials, p is the probability of success, and q is the probability of failure, then variance of the random variable is npq, and mean of the binomial distribution is np, whereas the variance is npq. So the square root of the variance is called standard deviation. If npq is the variance of the distribution, and standard deviation is square root of